everyone, and welcome to the tutorial for the mini project samples that I promised you last week. Okay, so we're going to go through the teaching plan first. Many of the students have been asking about the tests we have for the wind turbine and what will be due date for the quizzes and the other stuff. Actually, all the information are available for you on the canvas. So please visit the canvas. The teaching plan is here in the front of you. And you can see clearly that the hands-on fabrication experience testing for each class meant to be run in the week number 10. That's what's happened last week. Okay, and for next week, we're going to have the finals. So the finals meant to be run on Friday, and the subject coordinator said that for the student who didn't finish up the work last week, they can do it on Wednesday for the last catch-up session. The Friday session for the week number 11 is going to be the finals for the wind turbine testing. Now that's for the wind turbine testing. Starting from 2 weeks ago, or even we can say it's going to be last week, we start with the mini project, the other mini project, and you can find this one in the assignment section. We have another report need to be submitted, which is going to be the mini project study on manufacturing. But before we're going to go for the study on manufacturing, let's have a look for the design, fabrication, and the testing of the vertical wind turbine report that the student need to submit. So the rubric for this report is going to be as following. You can see that we need to have a written report expected to be approved and may include the sections in the point below. Brief introduction describing the purpose of the project, your project, not the wind turbine in general. Selection of your model, state which model design concept was selected, the reason for the selection, and the justification of the modification in the design that you've done, that describing every modification of the base model. You go for the section for the design presentations, the CAD drawings and or the handy sketch will be acceptable. Label the critical dimensions, tolerances, and the importance features. Section 5 is going to be selection of the materials. What are the chosen material? You can make a list of materials for each component, or to call the bill of material. Okay, justification like discussing mechanical, thermal, electrical, or chemical properties of the or as relevant. Consider the cost, availability, and sustainability. Section 6 is going to be the verification process, preparation of the raw materials, the cutting, shaping, machining, printing, steps that you have done, the assembly method, the tool, the machines, or the software used. Safely, precautions considered. 7 is going to be testing method. What is the setup? Okay, you can include schematic, illustration, and testing arrangement, testing procedure, and the test results. Present the data in a table and a graph if possible, and use a clear labels, units, and legends. Sorry, just remember something, that some of the wind turbine didn't work, so you just say, okay, now we had the concept, but the design failed, and this is a very normal thing. You don't have to worry about that. Okay, so once again, you add references if you had, like the website that we use, the conclusions, like said whether the objective were achieved or not, and that's it. The fabrication, you need to have a fully constructed vertical axis wind turbine. Photos need to be added. Link to the video for the lab testing, the one that we recorded in this session. So 9 points here, 1 point here, 5 points here. But definitely we need the proof that you made the things 5 marks, and the testing within these criteria should be considered. Okay, now let's go back to the assignments, and we're going to have a look now for the other project, which is going to be the study on manufacturing. So the outline of the project can be found here. Okay, and these are once again the marking criteria. I'm going to show you actually an example report, and we can go through the marking process that we had and what the feedback I gave them. Total point is going to be 30, but it's going to be later considered out of 25 points. If I get to have a look here, okay, so the intent is going to be the application of theory learned during the semester to a mini problems. Learning is going to be increased by applying the theory to practice. See the diagram below. We can here for the hierarchy of the design and manufacturing procedure. Okay, and if you're going to go through this one, you'll find what the task is. You need to have a group of students may select a suitable artifact, and the selected artifact is going to, or the focus main components are going to be compatible to a gear pump in terms of the size and the complexity. The artifact may be disassembled using the tools available in the Mechanical Design Studio, if you have one, of course, and the dimensions and the surface integrity of the components may be measured using the equipment available in the Mechanical Design Studio and the Metrology Lab. I know that many of you didn't use, are not going to use an actual components, and most of the things can be found from the online references, and you are going to use these points in order to discuss your report. So once again, the key points that may be addressed, including but not limited to: first, what are the artifacts used for, and how is the market? For example, what will be the quantity may be required? How does it work? What the main components will be focused on? And what is the working environment? What is the service lifespan is going to be expected? Like, for example, again, to work with the engine block, we work in a very severe conditions like the high temperature and the high impact and the vibration. And we expected the lifespan to be something between 5 to 15 years. Okay, what the materials property are going to be required depends on the application, of course, and what the materials may be selected to meet these requirements. So if I get to go to the engine block, usually it's going to be gray cast iron, but also I can use the aluminium as an alternative material. What are the dimensional tolerances and the surface integrity are required and critical? Now, if again to have the engine block, you know that the pistons and the cylinders should have very high tolerances between the moving parts. Otherwise, we're going to have either very tight or very loose, and in both cases, this will be wrong. What the fabrication technology may be adopted: casting or machining, additive manufacturing, rolling, okay? Any of the project that we learned during the semester. Plastic injection molding as a replacement for the for some of the sheet metal working is very common things nowadays, and even for the casting. The casting itself can be die casting, and it can be the sand casting, and it can be the, for example, the lost wax manufacturing methods. Now, what will be the working flow of the materials throughout the possible factory? So, for example, again, to have the raw materials, again, to have definitely in the factory, you're not going to do the working on the iron ore, and then you're going to melt it, then you're going to roll it, then you're going to cast it. No, definitely we're going to have it as blocks, or for example, again, to have some scrap, and you're going to melt it to do the, or it's ingot, okay? Actually, you're going to melt it and make the casting process, or you're going to have a block and you're going to do the machining on it, or you're going to have the plastic pellets and you're going to melt it and do the plastic injection molding. So basically we start from this level. So the plastic injection molding, we can get the pellets, we can add some coloring to it, we put it in the machine, and then we melt it, we inject it through the mold, cool it down, and take it and use it. So These are some of the workflow. You can make a flow chart that can replace a 2-page of writing. So what is the material wastage? For example, again, to have machining, I will have too much wastage. If again to have the additive manufacturing, I will reduce that, right? So that's what we mainly talking about. What may be the impact of the manufacturing process on the environment? Some manufacturing process is going to be more environmental impact than the others. So if we're going to have the casting, I have to melt the metal, and this requires very high energy, and this will causing too much of the gases to be emitted to the environment. If I'm going to do the machining, maybe this will be reduced, okay? But depend once again on the product itself, because different products going to require different manufacturing process. Sometimes we cannot escape the casting process. Okay, what is the cost? You can tell, okay, if I'm going to use, for example, die casting process for aluminium, the mold itself is going to be quite expensive because it's going to work with higher temperature. If I'm going to use a replacement for the aluminium to be a plastic with a high temperature resistance, then I can simply reduce the cost of the mold because the mold is going to work with a lower temperatures, and thus it can last longer. Just to give you an idea, for example, that the mold we're using for the plastic injection molding can cost you $150,000, and it can make 500,000 pieces. If I'm going to use a mold using the die casting for the aluminium, okay, this can cost me $150,000, and it can make 150,000 pieces. So the first 100,000 for 500,000 pieces, that's mean it's going to be around 20 cents per piece. If I'm going to go for the other one, it's going to be $1 per piece. So that's the thing you can think about it. Additive manufacturing usually going to take longer time for manufacturing compared to the machining and the casting process. But once again, this will depend on the quantity of manufacturing and the need for using the technology itself. Okay, so the project plan covering the point 1 to 3 needed for discussion after the approval by the teaching team. Some of the students actually approached us, others didn't, but I'm going to give you some example about the components that we need to use. Just remember something, that the wind turbine that we made in the lab cannot be used as an artifact for this project. Maybe you're going to get a real wind turbine, this will be okay. But the mini turbine we made is not acceptable. So for the written report and the video presentation, each group of 2, okay, again, to be needs to organize a written project report by addressing the assessment criteria in the rubric below, and there is no limits for the number of pages. As a reference, 15 to 20 pages may be suggested if A4 paper, normal margins, a single line space, and time Roman size 12 font were adopted. There should be a single page in the beginning of the written report to clearly documents each team member contribution for the individual marking. The personal reflection from each team member, about 100 words minimum, is going to be needed, including the use of the frameworks for the reflection and what worked, what didn't work, and what would you change if you're given the another opportunity, and what can set this up as a table of your, if you prefer. The report will need it to be submitted through the Canvas electronic version. A short video of presentation less than 3 minutes will be needed to be submitted, and every team members need to present in this video. Use a typical presentation format: introduction, body, and the conclusion summary. So just before we go forward to the 1 second, I need to exit that. Okay. How to join a team before we're going to go forward. So as we did, we go to the people and you try to search for the study on manufacturing sets. We have set 1 and set 2 because we have too many groups. So you can see that some of the students already joined the groups. You need to join any of these groups. I can see that many of them are empty. Just add yourself, you and your colleague. Because the number of the students is going to be 2, that's mean you can split the same team that you worked on the wind turbine into 2 different teams. Okay, just split in half. Do you like to make the project by your own? It's going to be okay with us. There will be no problem at all. Now let's have a look for some of the examples for the project that we had last semester for the highest marks. Okay, this report we can see in front of us. They scored 25 out of 30, and the project they used was the disc brake. So we have the disc and we have the caliber that contain the pads, the piston, and of course you know how this one's working. Talking about manufacturing process, I can simplify that to you. For the disc itself, it's going to be a plate cut by the shear cutting operation, press cut, and then we're going to add by compact some of the well, it can be considered as a powder work. Powder compacted and sort of sintered, or just using some of the adhesive to compact the pads that can be fixed on the plate, and the plate will be sitting in between the piston and piston 2 sides, okay, within the caliber, and the disc will be in between. This itself is going to be usually done by the casting process, and it's going to be machined to the shape. Usually they don't machine directly from a cylinder because the casted part is going to have a higher resistance to the thermal changes. Okay, so that's the disc, that's the flange. By the way, if you have something okay confuse you, that's the disc, that's the flange, that's the caliber, that's the piston, and here we have the pads. So let's have a look about what's happened. First, that's the table, the student name, student ID, contribution in this work. Table of the contents, introduction, the artifact functions, how it does work, what the variations and the types of the disc brakes, the part by part function breakdown, okay, design consideration, the manufacturing processes by part, okay, material and material properties, the part lifespan, the expected lifespan, the manufacturing and fabrication methods, the environmental impact of the production, and the part assembly and the implementations, and overall production costs. Student reflections given at the end of the project, and references and evidences. So just a brief introduction. What is it? Okay, the artifact faction, how does it work? The variation in the type of the disc brake, the hydraulic disc brake, we have the mechanical disc brake, we have the power assistant brake system, and electromagnetic disc type. Now I think that should be unnecessary, but they add a good addition to the report. Okay, so this part, because they're talking about a certain type of the braking system, so they don't need to cover the other things. They just put an extra work here, and this should be rewarded. So the part by part functions of the brake system, the brake pads, the brake calibers, that's many by the way, just casted and machined to get the tolerances, the disc brake, the brake hose and hydraulic fluid, the pistons. Oh, they're talking about the main piston. Okay, that should be okay. I thought they only talking about the lower part. Design consideration has been also mentioned. The manufacturing process by parts, so start with the brake disc, brake pads, the brake calibers, pistons, the brake fluids, the part lifespan for each part we have for the brake disc, brake pads, the brake calibers, the pistons, and the brake fluids. So we coming now to the section number 3 about manufacturing and fabrication methods. So once again, they start with the brake disc. Okay, it is, I mentioned that usually it's going to be cassette and then machined. If there's another way, you can find it online and add it to your report. The brake pads, well, that's what we're talking about, the process of making the pads step by step. The brake caliber, the piston, oh, this piston, lower one, I thought the main one. Okay, so once again, there are many ways to do that, but if I'm going to make it, I'm going to do it by machining from original or cassette part. The brake fluid. Now the environmental impact of each part. The disc brake pads. I'm not going to read that. It's already shown here. So once again, it's only about discussing what will be the environmental impact of the manufacturing process. Now, for the brake disc itself, it's going to be casting, then machined. Can we use another method to do that? It's going to be up to you. Is there a carbide disc brake? You check that. Okay, so if there's any other way other than the normal braking system that we know, you can write it down. Okay, so the brake pad, once again, we said is going to be some of the materials that can be compacted with the heat, or something like a sintering process to make it strong as we can. Can we replace it with something else? And it's going to be a better way to do that, lower cost and better for the environment. You can search and put that. Okay, the brake caliber and the piston and the brake fluid. Now for the assembly for the parts, you can get schematic diagrams. You can get diagrams from the internet and showing you this assembled part or the braking system. Then you start about the manufacturing process, step 1 to the step 10. Which one is going to go first, which one is going to go last, and in the disassembly, which one is going to go first and which one is going to go last, like what they're showing right here. Okay, the overall production cost, as I start to talk about the different materials. I don't know why they did use the aluminum. Usually I need to check, but I'm just going fast right now. So they talk about the aluminum, the iron, and the steel, the graphite, the rubber, and the fixed steel. So that's for the different material they use, depending on the amount that they use in the product. That can do a basic calculation for the total cost. And at the end, they just put a small short discussion about the cost of the product. Personal reflection part, this is an example. Okay, so Hamish wrote down 2 paragraphs. Andre did the same thing, and Declan or Ryan. So and they put the references at the end. I don't know what the appendices they had. Oh, the YouTube video and the presentation slide. I don't want to share this slide with you. I don't want to share the things with you, but I'm going to play the video for you because this should be fair. So this is an example for the video that those students done, and later I'm going to send you another example.
Have you ever wondered what allows a heavy truck or fast car to stop so quickly? Today we'll take you through a study on one of the most essential components of vehicle safety, the disc brake, a crucial component widely used in cars, trucks and other vehicles. Disc brakes are essential in automotive applications because they provide efficient, reliable stopping power, even under high speed and heavy load conditions. The disc brake assembly consists of several key components, each with a critical role. First we have the rotor, or disc, which is the part that rotates with the wheel and provides the friction surface. When the brakes are applied, the caliper, which houses pistons and the brake pads, presses the pads against the rotor, generating friction to slow the vehicle down while the mounting bracket holds the calipers securely in place. Another essential part is the brake pad itself. These pads, made of specialized materials, provide the necessary friction and absorb the heat generated during braking.
So when you were deciding on materials to create parts out of for your system,
I can see that the
they need to be
voice
justified
quality
by
is not
the
that good.
factors surrounding them. So one of which would be performance or efficiency, another would be durability, another would be cost. For our brake discs, heat is an important factor, so heat generation and dissipation of a certain material. Wear, which ties into durability, and most importantly would be environmental impact. So how impactful is it to the environment when it's both manufactured and also when it is disposed of?
That's fine.
If parts of it break down, such as brake pads
Watch
appropriately
quality is very
so
low.
that when they go into the environment, will they be detrimental? Are they safe?
Necessary to ensure all parts fit together properly, allowing the whole braking assembly to work as designed. Unfortunately, during and after the manufacturing process, disc brakes can have some negative impact on the environment. Some examples of this include material wastage during production, runoff from factories, brake dust released by the friction material, and harmful chemicals involved in the ceramic discs. These environmental hazards can affect those who come into contact with disc brakes regularly and damage the natural ecosystem. Ultimately though, compared to other manufacturing processes, disc brakes are only somewhat harmful in an ecological light.
Manufacturing disc brake mechanisms involve multiple different processes, which often vary depending on the type being produced. Sandcasting, machining, and tempering are all used for several components, such as the disc brakes and the housing, as well as sintering when carbon ceramic discs are involved. The surface integrity of the components, such as the discs and pads, are crucial in preventing corrosion, whereas it is less important for other components such as the housing.
To wrap up, our study of disc brakes has highlighted how this vital component ensures the safety of millions worldwide. By carefully selecting materials such as cast iron for its durability or aluminium composites for weight reduction, manufacturers achieve the perfect balance between performance and cost. Disc brakes are not just parts, they are lifesavers in motion and are a testament to engineering precision.
Okay, so that was an example video. They put that on Google. Yeah, I just remember last year I couldn't open it because it's required to have an access authority from the writer. Okay, so I don't want to have a long video, so I'm going to make the other example in a separate video.